This is a final review practice problem for college algebra. So the first problem, we're asking to divide 3.2 by 18.752. So the way we write this is we write 3.2 divide by 18.752. Okay, so because the denominator here is decimal, so you want to move the decimal point to the right in order to make this become a whole number. Okay, so we have one decimal place here, so we have to move it one place to the right in order to make this become a whole number. If you move this to the right by one decimal place, then we also do the same thing to the right side. Okay, so now we have a new system of 32 divided by 18.752, right? Because we move this decimal place here to here after the 7. So after you move this, you bring the decimal point here. Okay, so how many times 32 go into 187? It's going to 5 times. So let's multiply by 5 by 32. So 5 times 2 is 10. So 0, we have 1. 5 times 3, 15, plus 1 is 16. So after we multiply 5 by 32, we subtract them. So 187 subtract 160, that would be 27, right? Yes, 27. So now, after we have this, right, then we move down the 5 here. So we have 275 here. So how many times 32 can go into 275? I guess 8 times. And let's see. We multiply 8 by 32 to see what we get. 8 times 2 is 16. So we have 6. We have 1. And then 8 times 3 is 24. Plus 1 is 25. So because 256 is less than 275. So yes, we can subtract them. So 275 minus 256, that will give you 19. Okay, so after we subtract them, you move the last digit here 2 down. Now how many times 32 can go into 192? I guess 6 times. And let's do the multiplication. 6 times 32. So 6 times 2 is 12. So we have 12. We have 1. And then 6 times 2 is 18 plus 1. For the remainder would be 19. So now 192 subtract 192 is 0. So we have the remainder of 0. So this would be our answer, 5.86. So that this problem is asking for us to round this number to the nearest thousand. So remember, we have a decimal point here, and then we have the 1 place and 10 place, and then 100 place, and then lastly the 1000. It's not the last one, but in this case we are looking for up to the 1000 place. So here, if you replace this by this number, you have 9767, and then after that you can put the 0, right? Because we have nothing down here, so we put 0. So we want to round up to the 1000 place. That means we want to round up to this 9. So if you want to round up to this 9, you look for the one behind that, which is 7. So 7 is bigger than 5. So this number is closer to 10,000, right? Because this is 9,767. Now you round this 9 based on the one behind that 7. So 7 is bigger than or equal to 5. So we round this 9 to 10. So this number is actually closer to 10,000 for the 1000 place. So this become 9 become 10. So this is just 10,000 if you round all the way to the nearest 1000. So 9,767 would be closest to 10,000 for the 1000 place. Now we have a sentence, and then we want to write this using the digits. So we want to write 60,201. So 60,000, we already know 60,000 is 60, and then with 30, right? So 60,000. Now we have another 201. 201 is just basically 201. Okay, so if you add 201 or 201 to 60,000, we just get 60,000 and then 201, right? Because 30 here, when you add to 201, you just get 201. So 60,201. When we have the problem of prime factorization, recall that a prime is a number that is divisible by 1 and itself. So for example, 2 is divisible only by 1 and 2. 3 can only divide by 1 and 3, right? So it can only divide by 1 and itself. So if you want to factor 48, first, you know that 48 is an even number, so it's easy to divide by 2, right? So 48 divided by 2, which is 24. And 2, you know that this is a prime number, so we circle this. But 24 is not a prime number. You can divide this further by maybe 2, and then 2 is 2 and 12, right? 12 times 2 is 24. So 2 again, this is a prime number, but 12 is not. So you can further divide 12 into maybe 3 and 4, and 3 is a prime number, but 4 is not. 4 we can further divide into 2 and 2, right? And 2 and 2 now are all prime numbers. So now we multiply all the circles number here together to get the prime factorization of 48. So we have 2 times 2 times 2 times 2 times 3. So 2 times 2 times 2 times 2, 4, 2, right? 1, 2, 3, 4, and then 3. So this is the prime factorization of 48. If you want to simplify this, because we have 4 2's multiplied together, this is the same thing as 2 to the exponent of 4, right? 4, that means 4 times 2 by itself and multiply by 3. Okay, so we have two fractions here, 5 over 16 equal to n over 48. So recall that I showed you in the class, when we have two fractions equal to one another and we have one missing value, the technique that we are using to solve this type of problem is using the cross multiply. So 5 over 16, this is one fraction, equal to another fraction. So always, when you have two fractions equal to one another and with an equal sign in between, and you have one missing value here, we always can use the technique called cross multiply. So cross multiply this and this. So 16 times n, you have 16 times n. This is equal to 5 times 48. Okay, so how do you solve for n? Remember that we want to solve for n, so you want to cancel the 16 on the left side, because we have the multiplication here. So if you want to cancel the 16, the only way we can do this is by dividing 16, right? Multiply, then we divide them, so that you can cancel this. If you divide something on the left side of an equal sign, then you do the same thing to the right side of that equal sign. Okay, so now 48, you can rewrite 48 as 16 times 3, right? 16 times 3 is 48. So now, because the reason I want to rewrite 48 into 16 times 3, because I can cancel 16 here and 16 at the bottom. So you have 5 times 3 left at the top. 5 times 3, which is 15. So n here equal to 15. Okay, simplify this expression. So we have 15 minus 6, 9 minus 7. Okay, so we have multiply of 6 and we have the subtraction here. Remember that the order of operation is we do the multiplication, division first before subtraction and addition. So here we do the multiplication first. But before we do the multiplication here, we have something inside the parentheses. So you want to simplify the inside the parentheses first. So 9 minus 7, this is 2, right? So 2 here, and then 6, bring it down, 6 times 2, and then we still have 15 minus this. So we do the multiplication first. 16 times 2 is 12. Then 15 minus 12 give you 3. Okay, reduce this fraction. This is the same thing as asking to simplify the fraction to the lowest terms. So 56 over 72. Okay, so we know that 56 and 72 are all even number, right? So you can divide the top and the bottom by 2. So 56, if you divide by 2, it will give you 28, right? 28. And then 72 divided by 2 give you 36. Now this is again even and even number. So you can further divide it by 2. And 28 divided by 2 give you 14. 36 divided by 2 give you 18. Okay? So 14 and 18. Is it a simplified version? No. We still can further divide this by 2 at top and the bottom. So 14 divided by 2 give you 7. And then 18 divided by 2 give you 9. So can we divide 7 and 9 by a common factor? I don't think so. 7 and 9 cannot divide by any common factor. Actually, 7 is a prime number, right? So actually this is a simplified version. Or we can we reduce this fraction completely to 7 over 9. So we cannot divide anything by the same number on the top and at the bottom. So we end up at 7 over 9. Okay, so which one is the larger fraction? 4 over 7 or 5 over 8? The one that you want to know which one is bigger is the only way you can do this is by converting this to a decimal number and then compare which one is larger. Okay, so let's do 4 divided by 7. So 4 divided by 7. How many times 7 go to 4? So have a decimal point here, so bring up here, right? So 7 go to 4 0 times. So 0 times 7 is 0. So 4 minus 0 is just 4, right? Then bring down the 0 here. We still have many 0 after the 4, right? So 4 times, how many times 7 go to 40? I guess 7 times 5, 35. Yeah, so 7 times 5 is 35. So 40 minus 35, which is 5, and then bring down another 0 here. And then how many times 7 go to 50? 7 times 6 is 42, times 7 is 49, so 7 times 7 is 49. This is less than 50, so yes, that's good. 50 minus 49, which is 1. Bring down another 0 here. 7 go 1 time to 10, right? Because 7 times 1 is 7, less than 10, so 10 minus 7 is 3. And then bring down another 0. And then so on. This is not an even number, so this is, we still have many decimal after this. So, but roughly 4 over 7 is 0.571. Now, let's divide 5 by 8. Again, 5 just 5.000, right? Now bring up the decimal point here. So 8 goes 0 times to 5, right? 8 times 0 is 0. 5 minus 0 is 5. Bring down this 0. How many times 8 go to 50? So 8 times 6 is 48, right? 8 times 6 is 48. 48 less than 50, so 50 minus 48 is 2. Bring down here 0. But at this point, we already know this is 0.6 something, and this is only 0.5 something. So this must be a bigger number here on the right side. So this one is bigger. Right, you can stop right here because 0.6 is already bigger than this number. Okay, multiply two fractions. Remember, two fractions multiply together. Top by the top, bottom by the bottom. So 1/3 multiply 1/4. Top by top, bottom by bottom. So 1 times 1/3 times 4. This is 1 on the top. 3 times 4, 12. Here, in order to multiply the mixed number together, we first converting them to fraction. Okay, so 9 1/2. How do you convert this mixed number to fraction? Remember, if you want to convert the mixed number to fraction, we keep the same denominator, right? 2, we have the same thing here. And what about the top here? We multiply 9 and 2, then we add to 1. So 9 times 2, then we add the result to 1. This is equal to 18 plus 1 is 19/2. The same thing here. Convert 2/1/4 to fraction. We have the same denominator here, right? And then 4 times 2, 2 times 4 here. Add to 1. So 4 times 2 is 8 plus 1 is 9. 9/4. Now we have two fractions. Then you can easily multiply them together. Multiply 9/4. So top by top, bottom by bottom. If you do the calculation, 19 times 9 will give you 171, and then 2 times 4 is 8. Okay. Now, adding two fractions. What is the requirement for the two fractions to be added together? They need to have the same denominator, right? So, what is the common denominator of a and 5? So what number can divide both by a and 5? Well, look like 40, right? Because 40 is a product of a and 5, and 40 can divide by 8, also by 5. So how many times 8 multiply to get to 40? 8 times 5 is 40. So multiply on the top by 5 also. And then 5 times 8 to get 40. 4 times 8 to get the same thing here, right? Top and bottom. So now the new fraction here is 8 times 5 is 40. 7 times 5 is 35. 8 times 5 is 40. We want to make them to have the same denominator, right? So that's why we multiply by a here. And if you multiply a by that bottom, you do the same thing to the top. 8 times 2, 4, 32. So now they have the same 40 at the bottom. So we keep them the same at the bottom, and then we combine the top. And then 35 plus 32, this would give you 67/40. Okay. How do I subtract them? Again, if you want to subtract two fractions, the condition to subtract them is to have the same denominator. So, but then we have a mixed number here. So the best way is to convert the mixed number to fraction, because fraction is easier to work with, right? So first convert 7/4 to fraction. So we keep the same 4 here. 7 times 4 is 28. We add to 3, 31, right? And then this guy, 5/7/8. We keep the same 8. 8 times 5 is 40. 40 plus 7, 47. Now, 31/4 minus 47/8. We want to find a common denominator for an a. The common denominator would be a, right? Because a can divide by 8 and also by 4. So how do we make 4 become a here? We multiply by 2, right? If you multiply by 2 here, you also do on the top too as well. So you can rewrite this as this is A. And then 31 times 2, 62. And minus 47 over 8. Now they have the same A here. You can put them here. 67, 62 minus 47, right? And 62 minus 47 give you 15 over 8. So this is your result. Okay, so 8.4 minus 0.09. If you want to minus them, first line up the decimal point here. 0.09. And if you are missing something here, just place the 0, right? So borrow 1 from 4, give you 1 here, which is 10. 10 minus 9 is 1, right? And if you borrow 1 from here, this would become 3. So 3 minus 0, 3. And then 8 minus 0, 8. This is your answer. Okay, so multiply the product. The same thing, very easy. You have 3 products multiplying together, right? So the easiest way is find the product of the first 2, and whatever you get here, you multiply with 8.2. Okay? If you do the calculation, 0.8 times 2, let's do 0.8 times 2. 0.2 times 8. 8 times 2, 16. So we have 1 here. 8 times 0 is 0, plus 1 is 1. We have 1 decimal place here, so just put 1 move to just 1 place, which is 1.6. So 1.6 here times 8.2. Now 1.6 here times 8.2. 2 times 6, this is 12. So we have 1, 2 times 1 is 2, plus 1 is 3. 8 times 6 is 48. So A, we have 4. 8 plus 1 is 8 times 1 is 8, plus 4 is 12. Okay, this is, we can put 0 here. So add them together. This is 2. 8 plus 3, 11. So 1, we have 1 left. 1 plus 2 is 3. And then we have 1 here. And then we count how many places after the decimal. So 1 place, 2, so 2 places. So you move 1, 2, put the decimal here. So we have the answer as 13.12. Okay, so in this problem, we are asking to divide 96.3 by 0.3. So first, let's rewrite this in the format that we want. So 96.3 divided by 0.3. So can we divide this? No, right? We need to have the left side be a whole number. So you have to move this one place to make this a whole number. Then you do the same thing here, right? So we get 3, and then we got 963. Okay. So how many times 3 can go to 9? 3 times. So 3 times 3 is 9. 9 minus 9 is 0. Bring down the 6. How many times 3 go to 6? 2 times. 2 times 3 is 6. And then minus 6 minus 6 is 0. Bring down the last one. 3. How many times 3 can go to 3? Just 1 time, right? So 3 times 3 is 3 times 1 is 3. And minus 0, right? So the answer is 3 to 1. Okay, now write this as a decimal. I think in the previous problem I already there's the problem of comparing 4/7 and 5.8. So the way that we want to write this at a decimal is just dividing 5 by 8, right? And we did this before in the previous problem, and if you redo this, okay, so we have 0 here, right? 5 the same thing as 0, 5.0. So bring down the decimal point here. So 8 go to 5 0 time. 8 times 0 is 0. 5 minus 0 is 5. Bring down the 0 here. 8 times, how many times go to 50? So 6 times, right? 8 times 6 is 48. So 50 minus 48 is 2. You still have many 0 here. So bring down another 0 here. How many times 8 go to 20? 2. 8 times 2 is what? 16. So 20 minus 16 is 4. Then bring down another 0 here. How many times 8 can go to 40? 5, right? 8 times 5 is 40. So we have the remainder of 0 here. So your answer in the decimal point is 0.62 and 5. Okay, so we want to divide 16 by 0. So how do I do this problem? So 16 divided by 0. Okay, so how do I solve this problem? 0 is already a number here, right? With the 0 behind that. So how do I divide by 0? Actually, we cannot solve this problem. Something divided by 0 is undefined. So anything divided by 0 is undefined. So this problem doesn't exist. Okay? So you cannot divide by anything by 0. So if you see any type of this problem, this is an undefined problem. So just want you guys to know this. If you see this problem on a test, you know that this is an undefined problem. And how do we simplify the two fractions dividing one another? Okay, so if you have two fractions, the first one dividing the second one, the way that you do this is the same thing as the first fraction multiply the reciprocal of the second fraction. So 5/9 become 9/5. We turn the division here into the multiplication, but we have to flip 5 and 9 here. Okay, so if you multiply the two fractions, top by top, bottom by bottom. Now, can we simplify this? Yes, we can. 25, you can rewrite this as 5 times 5. Okay, and we multiply with 9. How about 36? We can also rewrite 36 as 9 times 4, right? 9 times 4 is 36. So now the 9 and 9 cancel here, 5 and 5 cancel here. You are left with only 5 on the top and 4 at the bottom. Very simple, right? Now, how do I write 1/8 as a percent? In order to write something as a percent, you need that number in the decimal format. Okay, so first we need to convert 1/8 to some decimal number here. So how do I convert 1/8 to a decimal number? Well, we just do the division, right? So 1 divided by 8. 1 is the same thing as 1.000, right? There's many 0 here behind that. So bring up the decimal point here. 8 go to 1 0 time, right? So 0 times 8 is 0. 1 minus 0 is 1. Bring down the 10 here. 8 go to 10 one time. 1 times 8, 8. 10 minus 8, 2. Bring down another 0. 8 go to 20 2 times. 2 times 8, 16. 20 minus 16, 4. Bring down another 0. 40. Now 5 can go to 40 evenly by 5. Right? 5 times 40. 5 times 8, 40. Subtraction here give you 0 for the remainder. So the answer is 0.125. Now 0.125 is the same thing as 1 over 8. If you want to convert a decimal to percent, the way that we do this is we move the decimal point by 2 places. 1, 2. So here 12.5%. So move 2 decimal places of the decimal number to get to a percent. Okay. Now we want to write the percent in a fraction format. And recall that 45%, when you see the percent, this is the same thing as dividing by 100. So 45% the same thing as 45 divided by 100, because percent is meaning dividing by 100. Okay. So can we simplify this fraction? Yes, we can. Dividing the top by 5, the bottom by 5. 45 divided by 5 gives you 9, and 100 divided by 5 gives you 20, right? Yes, 20. Okay, so 9 and 20. Can you further simplify this? I don't think we can. They don't have the common factor. So this is the simplest version. Okay, so now remember that before we in the previous problem we roll 0.125 decimal to percent. We move 2 decimal places to the right, to get 12.5%. Now you have the percent. We want to convert it back to decimal. That means we have to move it backward 2 decimal places to the left in order to get to a decimal format, right? So 6.5 now percent. We move it to the left by 2 decimal places. 1, 2. Put it here. So we put 0 here and 0 here. So this is the same thing as 0.065 for the decimal format. Okay. So from decimal to percent, you move to the right by 2 decimal places. From percent to decimal, you move back to the left by 2 decimal places. Now, this type of problem is very, very common. So let's solve this. In math, is represent for the equal sign. So we rewrite this. 20 is an equal sign. So what percent? That means we want to find something in here. We call that an x. Of, in math, this is a multiplication. Then 50. So we are looking for x here. We want to solve for x here. Okay. So this is the same thing as we have 20 equal x 50, right? You want to solve for x here. We have multiplication here, so dividing by 50, right, on both sides. You can get rid of 50 here in order to get the x here. So you have x equal 20 over 50. Now you can divide by 10 on both top and bottom. 20 divided by 10 gives you 2, and then 50 divided by 10 gives you 5. So this is 2 over 5, right? But they want in the percent, so you have to convert this to the decimal, right? And then you move the 2 decimal places to the right. So 2 over 5, this is the same thing as 0.4 in decimal format. And then if you want to convert 0.4 to percent, because they are looking for the percent, you move the decimal to the right by 2, right? And you put the decimal here. That means 40.0 or just 40%. Okay? In this problem, we are working with the percent increase. So the cost of apples has gone from, so this is the original amount, 0.59 cent to 0.89 per pound. Now we want to find the percent of increasing. Okay, so the original amount and the new price. So first you have to find the difference between them. So 0.89 minus 0.59. So this is 30 cents, right? 59, 69, 79, and 89. This is 0.39 or 39 cents or 30 cents. So the difference between them. Then if you want to find the price increase, the percent of the price increase, you have to take the difference between them. And then you take this number, divide by the original amount. So 0.30 divided by the original amount, which is 0.59. And if you do this division, you get 0.508 and then 47, and then we have a lot of more digits after this. And then here only the result here is only the decimal value. Okay, you want to round your answer to the nearest whole percent. So first, let's convert this decimal to percent. Remember, from decimal to percent, we move the decimal to 2 places to the right, right here. So this is 50.847%. Okay, but the question is asking for the whole percent, so we don't want the decimal point here. We want to convert it to the whole number, so we only take the 2 digits. Okay, so we end up at here, and if you want to take only 2 digits, we check the value after the second digit, which is 8. So 8 is bigger than 5, so we round this 0 to 1. So this is approximately equal to 51%. Now, this problem is asking us to subtract 2 numbers, right? And then we have 2 minus here, so minus and minus become plus, right? So 12, this is the same thing as 12 plus 4, which is 16. Now, this is an exponential problem. So here we have negative a squared. This is the same thing as this base multiplied by itself 2 times, right? So this is the same thing as this. And when you have 2 negative multiplied together, the 2 negative cancel, become positive, right? So this is the same thing as 8 times 8, which is 64. And here we have negative 10 subtract 4 multiplied by negative 9. So we have subtraction, multiplication here. We only do the multiplication first. So multiply these 2 guys together. 4 times negative 9 give you negative 36. Okay? And then bring down the negative side, subtract here, and then negative 10, bring it down. Negative minus another negative give you a plus 36. Then bring down negative 10. Negative 10 plus 36. This is the same thing as 36 minus 10, right? Negative 10 plus 6, the same thing as 36 minus 10. And 36 minus 10 give you 26. We want to find the square root of 81. Okay? So the square root means you will get some. If the square root of 81, you will get something some value here, and then if this value square give you 81. Okay, so you can rewrite 81 as 9 times 9, right? 9 times 9 is 81. And then the square root, that means we have a 2 in the root here. So 9 and 9, 2 times to give you 81. And if we take the square root, then this will become this. Okay, so 9 times 9, you can rewrite this as 9 square, right? And this 2 here and this 2 here cancel. So that means the square root cancel. You get 9, right, left here. Okay, find the least common multiple of 4, 8, 12, and 20. So first, let's find each individual multiples of 4, 8, 12, and 20. And we find the least, that means the smallest common, right? So the multiple of 4 is 4 times 1 give you 4, 4 times 2 give you 8, 4 times 3, 12, 4 times 4, 16, 4 times 5, 20, 4 times 6, 24, 4 times 7, 28, 32, 4 times 9, 36, 4 times 10, 40. Okay, and so on. Let's see for number 8, what will you get? 8 times 1 is 8, 8 times 2, 16, and then 3, 24, 8 times 4, 32, right, and then so on. But let we check all the numbers. Yes, here we need to find a common for all of them. So 12 times 1 is 12, times 2 is 24, times 3, 36, right? Times 4 is 48, and then so on. 20 times 1 is 20, times 2 is 40. So we still don't get any common number yet. Okay, so that's why we have to keep moving forward. So 40, then 44, 48, 52, 56, and 60. And then how about this one? 40, right? And then add 8 to this, 48. Add 8 to this, 54. No, add 8 to this give you 56, right? 56. And then add another A give you 62, and then another A give you 70. Hold on, I think I make some mistake here. Okay, this should be 64. Yeah, for 56 add A give you 64, and then add A give you 72, and then add another A give you 80, right? Let's see, we still don't get any common number. 12, you add 12 to 48 give you 60, another 12, 72, another 12. Hold on, we have 72 here, 72 here. Let's see this one, 64, 68, 72. Okay, but for 20 we still don't get. So 20, 20, 40, 60, 80, right? And then 100. Okay, let's see, do we make any mistake right here? Let's see. Okay, we still don't see any common number. That's why, that means we have to move forward. So let's move with 120. Okay, let's see this one. So add 12 to this gives you 84, right? And then add another 12 to this gives you 96. Another 12 to this gives you 108. And then another 12 to this gives you 120. So we have 120 here, 120 here. Maybe 120 is the common. So let's see, 80. Add 8 to this, 88. Add 8 to this, 96. Add 8 to this, give you 104. Add 8 to this, give you 112. Add 8 to this, give you 120. Okay, so 120 here, here, here. It looks like that 120 is the common factor. Okay, 72. Add 4 to this, 76. Add 4 to this, 80, 84, 88, 92, 96, 100, right? And 104, 108, 112, 116, and 120. Okay, so 120 here. We are matching here now. 120, 120, 120. Okay, so 120 is the least common multiple of these four numbers. So this problem is hard. You need to list all the common factors here for 4, for 8, for 12, and 20, and find a matching value. So just list them until you get a matching value for all of the numbers. Now, subtract 9, 10 minus 1, 3. Okay, so in order to subtract them, we need a common denominator. So 10 and 3 have a common denominator of 30, right? So 10 multiplied by 3 to get to 30. So multiply the same thing here. And 3 multiplied by 10 to get to 30. So multiply the same thing here. 9 times 3, 27. 10 times 3, 30. 10 times 1, 10. 10 times 3, 30. Now, the same bottom, 30. And then 27 minus 10. 27 minus 10. 27 minus 10 gives you 17 over 30. Okay. So again, this type of problem is pretty easy. So 48%, that's mean dividing by 100, right? So 48%, that's mean, or you move to the decimal places, which is you move to the left by 2 decimal places. So here and here, you get 0.48 for the decimal place, right? For the decimal number. So converting 48% to decimal number, which is move 2 places to the left. So 48%, that means 0.48 of. Recall that I told you before that of in math, of that means we multiply. So of is multiplication. So 48%, that means 0.48 of multiplication. 900. So this is equal to something, right? That is the value we want to find here. So 0.48 multiplied by 900 gives you 432. So you find that value here. That means you multiply this guy by 900 because of is multiplication. And 5, that means x equals something. Okay, similar type of question. 31, bring it down, is equal, right? Equal sign. 16, we move 2 decimal places to the left. 0.16 of is multiplication. What number is we call maybe A, right? So you want to solve for A. So we can rewrite this as 31 equals 0.16 multiplication by A. You want to solve for A. A, we call this a what number? So dividing 0.16 on both sides to cancel here, right? You get A equal 31 divided by 0.16 gives you 193 You can use the calculator to do this. 193.75. Okay, so this number is 193.75. This is the number we're looking for. Similar type question. A50, bring it down, is, this is an equal sign. What percent we call is maybe x variable of its multiplication, and then bring down this, right? 3400. So remember, of the same thing as multiplication, right? And then is, this is equal sign. Okay. So now we want to solve for x. That means we're dividing by 3400 by both sides. Cancel. X equal A50 dividing by 3400 give you 0.25. Remember, the question is asking for the percent, so we have to convert from decimal to percent, which means we move the decimal to 2 places to the right, which is 25%. Okay, so this question is asking us to solve the equation here. And solving an equation, that means we are looking for the value of the variable z here to make this equation to become true. In order to solve for z, you want to eliminate z on one side and the other values on the other side. So first, you see that we have 11z here and 6z here. So z are now in both different sides of the equation. So we must move z to one side of the equation and then the other number to the other side of the equation. So let me move z to the left side. So if I want to eliminate 11z on the right hand side here, I must subtract 11z, right? Then I do the same thing here on the left side. So 6 on the left side now becomes 6z minus 11z minus 3 equal this and this cancel 7 here, right? Now 6z minus 11z, which is equal to how much? 6 take away 11, which is minus 5, right? Minus 5z minus 3 equals 7. Now we still have some number here, so we need to move this number to over here. So in order to cancel negative 3, we need to add 3 on both sides. So this negative and positive go away. 7 add to 3 equal 10, and we have negative 5z here. Now in order to solve for z, you still have to get rid of negative 5 here. So we have multiplication with negative 5, so we have to divide by negative 5 on both sides to cancel the negative 5 here and here. You have z left. 10 divided by negative 5 gives you negative 2. So z is negative 2. The answer is z equal negative 2. And in order to check if this is a solution to the equation here, you can plug in negative 2 on the left side here. So 6 times negative 2 minus 3 gives you 6 times negative 2, negative 12, minus 3 gives you negative 15, right? And on the right hand side, 11z, that means 11 times negative 2 plus 7. 11 times negative 2 gives you negative 22 plus 7, which is negative 15. So yes, they are equal to each other. That means z equal negative 2 is a solution to this equation. We have another solving equation for x here. So we have 4 over 5x equal 12. So now you are looking for the value of x here. You want to solve for x on the left side, right? So we need to move all other numbers to the other side. So we have a multiplication here. In order to move 4 over 5 to here, you need to cancel it, right? So in order to cancel this, you need to divide by 4 over 5 on both sides, right? This go away. So you have x left. X equal 12 divide by 4 over 5. If you divide by fraction, this is the same thing as you multiply by its inverse, right? So multiply by 5 over 4 instead of 4 over 5. Okay? So 12 is the same thing as 12 over 1. And then multiply, that means the top by top, bottom by bottom. So 12 times 5 over 1 times 4, right? And this should be 12 times 5 is 60, divided by 4 times 1 is 4. 60 divided by 4 give you how much? 60 divided by 4 give you 15, right? Because 15 times 4 give you 60. So this is 15. So x is 15. And you can check that indeed x is a solution for this equation by plug in back 15 to this equation. So 4 over 5 multiplied by 15. 15 divided by 5 give you 3, right? 3 times 4, which is 12. So that's correct. Okay. So we want to find the value of this expression. And given that we have x equal -4, y equal -2. So we have 3x plus 2y divided by 3. So x now is -4, y is -2. So whenever you are seeing x, plug in -4, and when you see y, plug in -3. So 3x -4, right? Plus 2y is -2 divided by 3. 3 times -4 gives you -12. 2 times -2 gives you -4 over 3. -12 minus 4 gives you -16 over 3. This is your answer. Okay, so this problem, we have a fraction, and we want to write the fraction as a mixed number. In order to write this as a mixed number, you have to use a long division, right? So for fraction, 35 over 6, this is the same thing as 35 divided by 6, okay? So how 35 is the same thing as 35.0, right? And 0, 0, so on. You move up the decimal point here. So how many times 6 go to 35? 6 times 6 is 36, which cannot because 36 is bigger than 5. So 6 times 5, yes, 6 times 5 is 30, right? So that's good. 6 times 5 is 30. 35 minus 30 give you 5. So if you want to convert this to a mixed number, we keep the denominator 6, right? And whatever we get here, the result for the division, we place it in here, and the remainder we place it on the top. Okay, so you divide this, and the result of this one you place it in front. The remainder you place it on the top, and you keep the bottom here. So the answer is 5 over 6, the mixed number. Now, this is a more complicated problem for solving for x. Remember, when solving an equation for x or other variables, the only way you can solve that is you're moving x to one side and the other number to the other side. So now it's look like that on the left side we have x, on the right side we also have x. So we should move this one to the right side. So we want to cancel this on the right hand side. We add 311x, right? So we can cancel this guy. But we also need to add to the right hand side too. So now the left hand side become a11x here. Then add to 3 over 11x. Add to 1/2. And the right hand side we cancel this already. So we have 4 over 9 plus 4 over 9. Now we have two fractions. We want to add them together, right? This is the same thing as ax over 11 plus 3x over 11 plus 1 over 2. And we have the same denominator here, so keep them the same. combine the top, 4 plus 4, right? This is equal to 8. 4 plus 4 is 8 over 9. So we can also combine this one, right? 11 at the bottom. So 11 here, 8x plus 3x give you 11x, right? And plus 1/2 equal to 8 over 9. And look at this, 11 and 11 on the top and the bottom, we can cancel this. So this would become x, actually this become x plus 1/2 equal 8 over 9. In order to solve for x, we need to cancel 1 over 2. So minus 1 over 2 on both sides. This gives you cancel this guy. So x become 8 over 9 minus 1 over 2. Okay. And 8 over 9 minus 1 over 2, if you do the subtraction, right, we need a common denominator of 18 because 18 divide for 9 and 2. So this multiply by 9 to get to 18. The same thing at here. 9 times 2 is 18, so multiply by 2 here. So we get x 8 times 2, 16 over 9 times 2 is 18. Minus 1 times 9 give you 9. 2 times 9 is 18, right? So the same denominator here. Combine the top, 16 minus 9 give you 7 over 18. So your x is 7 over 18. Okay, so move all the x to one side, all the number to the other side, and then simplify that until you get only the x on one side. Okay, this problem is very interesting. When the smaller of two consecutive integers is added to 2 times the larger, the result is 26. Now you need to find the two integers here. So the key word here is we are having two consecutive integers, right? So if I call the first integers x, okay, the first one, then the second integers need to be x plus 1 because they are consecutive. That means one is bigger than the other by 1, right? So if we have x for the first one, then the next one, the consecutive integer, the next one should be that one plus 1 because they are next to each other, right? So this one is x, the next one should be x plus 1 because they are next to each other, consecutive. So x and x plus 1, this means this number is small, the smaller, right? And this one, because they are adding to 1, so this is the larger number. So the first number is x, the second number is x plus 1. So this one is the smaller, this one is larger. They are consecutive integers. Now, the question says that when the smaller of the two, so in two number here, the smaller, that means the x. So when this smaller is added, so we add it, right? We plus 2 times, that means 2 multiply the larger is this guy, x plus 1, right? So 2 times the larger, 2 times x plus 1. Okay? The result is 26. That means this is equal to 26. Now they want you to find these two guys here. What are the values? But we can construct an equation like this from the wording here. Now you need to solve for x. Okay? So x will equal to some number. And this number is the smaller one. Then you add 1 to that to get to the larger. Then you get the two numbers. Okay, so how do I solve for x here? We have the parentheses here. So first, distribute 2 inside first. So x plus 2 times x is 2x. 2 times 1 is 2. Equal 26. And then combine the like term. We have 1x here. We have x is just 1x, right? One imaginary number here. So 1x plus 2x, 3x plus 2 equal 26. Now you want to eliminate x on one side and then the numbers on the other side. So we have plus 2 here, so we need to minus 2, right? On both sides to cancel here. Then you have 3x equal 26 minus 2 gives you 24. Now you want to solve for x. So we have 3 times x. That means we need to divide by 3 on both sides to cancel the 3 because we are looking for x, right? So 24 divided by 3 gives you 8. So x is 8. That means the first number, the smaller number is 8. And the larger, the next one is 8 plus 1. That means 8 plus 1 is 9. Okay, so we have two numbers. One is 8, one is 9. Two consecutive integers. That means we found the first one is 8, then we add 1 to that to get the larger or the second one, which is 9.